Button to start. Am I actually live? I'm not really sure. I have no idea what I'm doing. Oh, there we go. I mean, stop streaming and broadcast. Hey, somebody's here. Can you hear me? I really have no idea if I'm actually live or what's going on. I'm still kind of getting the hang of this. I think I have a feedback loop going on somewhere. I gotta turn that shit off. Sound of video coming through. Excellent. I've been playing around with the compressor on the audio stream with my microphone, so hopefully I got the settings like reasonable and you guys can hear me. Excellent. Need another like 30 seconds and I'll get started. Fantastic. All right, great. Well, I think I'm gonna get started. Like I mentioned in the comments, the general theme about the stream this afternoon is going to be we're gonna dive into all of the pains in the I/O configurator. What song is it? I don't even know. I bet there's a little plugin I can use to show my Spotify playlist in the stream, isn't there? There has to be. It's Watch It Grow by Creature with an E and a K. The song is great. So the general idea behind this stream is we're going to go over all these tabs and actually dive into what they're doing, and then we're going to actually get into the I/O configurator and go over all of that stuff in pretty great detail. And after that, Q&A and maybe just like hang out and make a patch or something like that. Before we get started, just a reminder, the contest is still live and runs until the end of the month. So for those that aren't aware, I'm giving away one brand new HDK 01 glitch effect processing unit in exchange for just a picture of your live studio setup with the Recursion Studio, or you using the Recursion Studio in the field. All you have to do is post that picture in the Discord gallery or email it to me, either at Gene@Entropy & Sons or contact at Entropy & Sons. Basically anything at Entropy & Sons will go to me. So yeah, that out of the way, let's get started. So let me change the camera view real quick. So we're gonna be zooming into this in pretty great detail. So I'm gonna try to get it all in focus and looking nice and clear. All right, so there are 4 general classes of inputs that the synth takes. Actually, there's a 5th one we'll get to too, if you count the knobs and buttons on the synth, which you should because they're controlled in the exact same way. So you are probably aware you can run audio into the synth. You can control it via CV. You can run video cameras into it, and you can control it via MIDI. The 4 tabs organize all of this and give you access to all of the ways of configuring it and controlling all of the information with the synth. Before we get into that, I just want to make it do something interesting so it actually looks cool. There we go. Yeah, so in general, there are 2 ways of controlling the synth with any of these 4 types of inputs. You can either wire data signals directly into parameters or use mappings to kind of connect the input signals to output actions, or there are some modules that directly visualize data. For instance, for the audio input types, there are a handful of modules that actually give you audio waveforms that you can just directly integrate. That's actually what's happening right now in the synth. All of the lines that are coming through in this shape are directly created by a module, which is just directly responding to the audio. Similarly, there is a couple of CV modules that you can just run directly into the synth as well. For instance, so we're not going to focus on these modules in this video, but I just kind of want to show you an idea of what it's doing. So this is actually it's graphing a oscilloscope, and you can directly control that with the CV inputs. So it's actually giving you a direct render of CV data. Similarly for video, there are video texture modules that you can just use directly in the system. For MIDI though, there is no direct MIDI visualizer at the moment, although I am definitely going to make one. So yeah, the general division for getting inputs from these 4 control types is whether you actually create like a mapping to map the direct control value to some kind of action, or if you directly visualize it with a module. So in the next stream, next weekend, we're going to go over the modulation system and some of these visualization modules. In this stream though, we are going to focus more on the I/O mappings, which I think are still a little bit of a mystery to a lot of people, and they are fairly sophisticated and a little, complex. So we're going to dive into that in great detail. So we have 4 I/O types, and we're going to start on the MIDI one because in a lot of ways it's the easiest to understand. So I have, first of all, to clarify, in this stream, I have a display plugged in, power plugged in, as always. There's audio plugged in, and over here I have a video camera plugged in and a MIDI controller plugged in. It's actually the one that somebody posted to the stream the other day. This is actually a great little MIDI controller. It's not going to be in view for the majority of the stream, but just know that it is actually plugged in, and I'll be sending MIDI signals with it fairly regularly. But yeah, so each input type has its own little configurator page. The MIDI configurator is the most straightforward, but we're actually going to get into the details of what everything does on all 4 of these pages, just because that's what we're doing in this stream. So all MIDI. So first of all, if you do something on your MIDI controller and it's plugged in, it's actually going to echo what it is actually displaying, or what the signal is getting. So I'm just moving a knob on my MIDI controller, and it's sending a MIDI CC signal, and it tells you the channel and the value. And I'm pushing a button, it tells me that it's getting note on and note off events. So it'll show you both what it's getting as an input and also what it's outputting. And if you will notice, there are 2 5-pin ports on the back. I always normally just use USB MIDI, but the device does support 5-pin MIDI. It has a couple of functionalities on this little panel that kind of let you control that. It's fairly straightforward. So first of all MIDI messages come with a channel. It's basically a way of like filtering them. It's not super important, but right now it's listening to all input channels, and it's a way to like basically route a bunch of MIDI over networks when you have a bunch of devices on the same device or like same grid, and you don't want to always be using them in every circumstance. But anyways, this first little configuration right here just basically tells you what channels the device is listening on, and it's by default to all. Underneath of that, there's MIDI pass-through. So basically the only thing at the moment that the 5-pin out jack on the back does is pass through MIDI, and that can be selectively disabled and turned on and off with this button right there. Actually, wait, no, that's not true. You can actually send messages back out of USB if you have something that's actually listening for messages. So you can pass through messages both over USB and 5-pin. I forgot all about that. And you can toggle them on and off of these settings. And output basically lets you change the channel of what you're actually reading. It's not super important. Anyways, basically all you need to know right now is that we're getting MIDI messages, and we're going to start actually making them do something. So let me turn off the full screen view real quick and go back to here. And also load something interesting again. All right, so in order to actually do something with the MIDI messages, we have to go into the MIDI I/O configurator, and these were from earlier, so let me delete those real quick. And actually tell it to do something with the signal. So we're going to kind of skip through this page right now and actually go into creating a new mapping, and we're going to come back here in a second after we've covered the second page. So yeah, what we're going to do is we're going to create a new mapping. And let me focus my camera real quick. All right, so the general concept to understand for I/O configuration is that of a mapping. And so a mapping connects a signal to an action, where a signal is any of the multiple I/O types, either audio, CV, MIDI, or from the UI, the knobs or the buttons on the synth. And actions basically let you do something. And there's 3 categories of those: setting parameter values in some way, turning on and off internal LFOs, and also system actions. And we're going to go over all of this right here. So the first thing we're going to do is actually select an action. So the synth has a learn functionality. So basically, well, first let's go over this right now. So the actions in this mapping editor are divided into 4 categories for the 4 major mapping types. Something to know, there are no signals that come from video. Video only works in modules. So there's a couple modules that visualize the video, and that's the only way at the moment to do anything with video. But with all these other I/O types, you can wire the actual values directly into actions on the synth. So there are 4 categories of actions: MIDI, CV, and audio, like you saw in the previous configurator, and also UI, which includes the knobs and the buttons on the synth. So yeah, 4 tabs here, pretty straightforward. You can long press on any of these to actually get information about them. It's the help feature. And there is also a learn functionality. So learn, well, once you push it, it's going to sit there and wait for you to do something. I'm going to turn a knob, and it's detected I've turned the macro knob 1. I'm going to go back to that and learn, and then tap a button, and it's detected I've pushed button 1. So it's, instead of actually having to manually input all this stuff, you can do it with the learn functionality, which is what I would recommend. So the vast majority of signals come with something like a channel, and that's right here denoted as CC. It's basically a way of differentiating various signals. For instance, for the knobs on the synth, it'll give you a value from 1 to 15. The first 5 are on the first page of knob controls, the second 5 on the second page, and so forth. MIDI note on will give you a note number. So there's often a numerical way of differentiating all these notes. And another thing to know is that the vast majority of these signals also come with a value. For instance, if you were to select CV and read from CV channel, definitely not 37, CV channel 5, it's going to send a value over that channel. And the value is almost always just a number from 0 to 1. In this instance, it tells you the level of the CV signal. For a MIDI CC, actually let's do learn. For MIDI CC channel, it's going to tell you the actual numerical value. So you may or may not know that MIDI CC sends, I think, 0 to 127, and this is normalized, so you divide by 127 to get a value from 0 to 1. If you're playing around with a button press in the UI, for instance button, it's going to send you a value of 1 for the pushing down the button part and a 0 for the release. So it's actually going to send you 2 signals, and you're going to need to use this filter over here. It's a value filter. So in order for this signal to not be triggered twice, you use the when action right here, which lets you filter when it actually happens. So since the button press sends 2 signals, this is going to filter out the one that sends the value of 0. So this is kind of interesting because there's actually a couple of options here. The default is always. So if we had this right now, then a button press would send a value of 1 for the press and a value of 0 for the depress. So by default, it uses a threshold. And it has just a couple of options. Another thing to be aware of is a gate. So you could, for instance, be listening on CV channel, I don't know why it's defaulting to 10, CV channel 5, and then wait for the value to rise above 0.5, so that's the midpoint. And then whatever you are configuring this mapping to do would only happen once the CV signal transitions past that threshold. And you can have a falling threshold too. So this is useful for like clock pulses or something like that, or if you wanted to do something on each clock pulse. You can also just wait for the value to change with the changed action or changed when right here. But anyways, that's a general idea of what's going on with the signals. So you have a collection of signals. Each one has some type of channel, or the majority of them have a numerical channel associated with them. PC keyboard, that is, I think, the ASCII value of the key that you pressed or something like that. we'll get into all these details in a minute. Right now, we're focusing on MIDI, and we actually handle a couple of different MIDI messages. We handle note on, MIDI CC, program change, pitch bend. There's also key tracking and key poly, which are specific to this synth. So key track will basically give you a value from 1 to 0 that tells you which note you've pressed. So if somebody is playing like a high note on a keyboard, the value will be closer to 1, and if they're playing a low value, it'll be closer to 0, so you can actually map that up to something. Key poly gives you a value from 0 to 1 depending on how many keys you have pressed at the same time. So it's basically like a chord detector. So if you have like 5 keys on a keyboard pushed at the same time, it'll give you a high value. If you have no keys, it won't send you a signal. But so yeah, so that's the overview of what's going on in the MIDI events right there. So we are going to not get too distracted and attach something to this MIDI CC value for this knob that I've been turning. This is a great patch. All right, so mappings in general are connections of signals to actions, where a signal is some kind of external control signal with a value on a channel, and an action is one of these 3 types of things. So there are value actions, which let you numerically set parameters throughout the synth in a variety of ways. There's LFO actions, which basically are toggle on and off for LFOs. And then there's system actions, which are kind of miscellaneous. There's a big collection of them in here, and we're going to go over all of these. So for value, you have 6 different ways of controlling a parameter value. The most straightforward one is set value, which just sets the numerical value of a parameter. So we're going to choose the width parameter. Now there's a bunch of options. So yeah, hope you guys aren't bored yet, because there's a lot of information to go over here, and I'm going to go over all of it. So there's a bunch of configuration for an action. So once you have selected an action, you go into the secondary menu here, and there's 2 tabs. All actions share these right here, and these are specific to the action you have selected. So what we are doing is we're setting a parameter value. We're setting the value of we're setting the value of the width parameter, and we have to figure out exactly how we are going to set that value. There's a bunch of options. So the most important one is what we're actually setting the value to. So the signal value is the value from 0 to 1, which is effectively the value of the MIDI CC value. But there's a bunch of different options here. What's the best way to cover this? So most of them aren't relevant for a set value action, but you can either numerically have an explicit value. For instance, if you like push a button on like a MIDI button, you can have this set this parameter value to like 0.5, for instance. Or if you do default value, then you've essentially made like a reset control. So, but these aren't really quite relevant for a knob. And there's instances where you want this to be like the current value, but I'll get into that in a second. You can also have buttons do random things, which we'll also get into in a second. There's an attack control. Oh, so first of all, let's just save it with the default, just to be obvious what we're doing here. So we've created a control, and we're now in the mapping list page. It's 1 level up from where we just were, and it shows you that there's a MIDI CC70 mapping to the width parameter with a set value action. Screen looks a little blurry to me. So now I'm going to control that MIDI control. So I'm setting the width down to 0. I'm setting the width to 1, for instance. You can't see my hand doing it, but that is what I'm doing. So that's with the default setting. So there should be some fairly sensible defaults for each of these mappings. But there's a wide degree of configurability. So you can put an attack on it, and that is going to make it have some kind of inherent smoothing. So another thing to know, is that there are 3 major methods of timekeeping in the synth. If you haven't come across this yet, this is definitely pretty worth knowing. There is milliseconds, there are frames, and there are beats. So a millisecond is the basic unit of time. If you're using that, yeah, it just fixes to like actual real world time. So the synth runs at about 30 frames a second, and you can actually do time measurement in terms of the frames. So if you could set, for instance, some kind of action to take 1 frame to execute, then you can actually sync things up directly with the frame rate of the synth, and you get some really strange effects that way. The most common use case, though, is with the beats action. So the synth has, at any point in time, an internal sense of the current tempo. Most of the time, you're getting that from audio, but you can also get that from like MIDI clock, for instance. And beats is basically a measure of time that corresponds to the tempo of whatever you have running into the synth. So you definitely don't want that in this circumstance. But if you add, for instance, a really long attack, then we've basically got like a smoothing effect on this knob, and it's going to be really laggy, which is probably hard to see without actually seeing my hand. But I'm just doing a really brief touch, and it keeps going after I've done it. This can be useful for just like smoothing out signals. But by default, it's 0, because that's almost certainly what you want it for in this particular instance. You can change. So in this set value action, when it receives this MIDI C signal, it moves the value that the parameter currently is to the target value, which is the signal value. Attack is how long that takes. So with 0 milliseconds, it's instantaneous. Release can be useful for creating envelopes, but we don't want to do that here. We can do that when we use buttons. And a path is, I can also explain that in a minute. So yeah, some of these are a little more relevant when you're using like a button as opposed to a knob control, but they're still here regardless. So you can also set the range of the output value. So the width parameter generally accepts a value from 0 to 1, but you can constrain it to 0.5 to 1, for instance, and then it basically limits the range of the width control. And again, all of these you can hold down on, and it should give you information. So in the common tab, you see information that's shared across all action types. So there are 3 of them here. The first one is probability. So with the probability of 1, it's when the synth receives the signal for this mapping, it's always going to do the action. But you can set the probability to 0.5, and then it's only going to happen 50% of the time. Another random thing to know is that you can map an arbitrary number of signals to an arbitrary number of actions. So, for instance, you could have a MIDI note on event. For instance, to this button, and map it to like 12 different LFOs, and then only have a 5% chance of turning them all on. So every time you push the button, something different is going to happen. So you definitely have the ability to control the thing probabilistically here too. So you can also add a delay to an action, which basically lets you turn this thing into a sequencer. So you could map 5 note on events for the same note to several different actions and stagger them by different delays, and then you just get a sequence of events every time you push the button. The last one is label, and that's basically used on the perform view and a couple other places in the UI to actually give you a name for this mapping, just for quick identification. Anyways, back to this view right here. All right, so we're still playing with the width control, but now I have a note on event. All right, now I'm going to make, what's going on here? Oh wait, that's not how that works. Yeah, every time I push this button, it's gonna set the width value down to 0. Oh, I have to save it first. All right, width is gone. And now I'm gonna use the synth controls to reset it. And now I can make the attack like take 8 beats, and it's analyzing the audio and extracting the tempo from the audio. Another thing to know, there's also a trigger button right here where you can just trigger the events without actually having to trigger your IO controller. So here, just tap trigger, and then it should take 8 beats to take the width all the way down to 0. See? That's basically what the attack does. So when you push this button, it moves the width parameter from its current value down to value, and you can change the path. You only have 2 options. Linear is just a line, and smooth is a little bit less jerky of a line. So I think that's it for this page. We also have a couple other options here. We can, seeing as we got to this page via the edit action, we had the option to basically clone the mapping down here, and now we have a second one. We can also disable the action. Instead of actually deleting it, now it's just not used. All right, so we're gonna go through a couple more of these actions before we get into any more details. All right, so increment value is another way to set actions. The major use case for this is for infinite encoders. So a MIDI CC message basically has a fixed value depending on the absolute knob position. The value is from 0 to 127, and the synth gets a value from 0 to 1. So with an infinite encoder, you don't really have that option, and the knobs on the synth are infinite encoders. So the way this action works is that it works relative to the current value of the parameter. So when you turn a knob, the actual value you get sent is a value from -1 to +1 that tells you how fast and in which direction the knob has been turned. So this lets you basically increment or change a parameter's value incrementally. And there's an attack that gives you a little bit of smoothing on that. It's fairly important in this circumstance. And the other parameters are basically the same. You can map the output range, and you can tell the way the pathing works. So there's other actions. There's attack release envelope. So we can trigger this, and what actually is going to happen? Let's see. Yeah, there we go. So the signal value coming from pushing this trigger is a 1. So it takes the current parameter from its current value to a 1 over a 0.25 beat attack, and then it releases back to the previous value. So it's just a simple envelope on this parameter. So toggle value, that basically sets the value to 1 minus the current value. So right now, I don't even know what the width value is, but we'll turn it all the way up to 1. And you trigger this event, and it goes to 0 over a 1 beat attack time, and you press trigger again, and it goes back to 1. There are some like Boolean values in the synth where you turn some feature on or off, and this is very useful for that. Reset value, every parameter has a default value, and yeah, press trigger, and it puts it to the reset or to the default value. Random value, also pretty straightforward. Just completely randomize the value. All right, there's also a collection of LFOs in here. This is fairly straightforward. They all basically have the same type of controls. So yeah, we don't need to go through all of them, but I think there's like 6 or 7 types. And again, these share the same common control, so you can randomize them and put them on delays and stuff like that. So there's a couple of settings for the LFOs. Minimum and maximum are, I think, hopefully fairly self-explanatory. It gives you the maximum and minimum points of the actual oscillation. So this is going to create a sine wave LFO that's oscillating over a period of 8 beats. It's going to take 1 beat to go from the width value's current parameter to the start point of the LFO. And if there's a release value, when you turn off the LFO, it'll take that amount of time to return to its current value. So let's just press the trigger button right here and then turn on an LFO. I'm actually going to make it a little bit faster, just so it's visible. So I trigger again, should have turned the LFO off. There we go. Now I have an LFO running. So one thing to know, so I mentioned earlier that all signals provide a value. Pushing a button down sends a 1, releasing a button sends a 0. So LFOs work in 2 ways. They are most of the time they're toggle, where you send 1 button press, it'll turn the LFO on, and then you send another full button press, it'll turn the LFO off. But if you hold down a button on your MIDI controller, it turns it actually, or on the synth, the LFO will be temporary. So I don't know if you guys know this, but let me go back to this view. So there are a bunch of LFOs here. If you hold down the button, the LFO is only going to last as long as you're holding down the button, or you can just tap it. Useful in some circumstances, I'm sure. All right, I'm getting bored of this patch, so I'm going to go change it real quick. There. So yeah, there's sine wave LFO, triangle wave, saw wave, square wave, constant wave, which is useful in some fairly obscure circumstance. That just outputs like a solid value. It doesn't oscillate. Step wave is kind of interesting. This actually kind of takes discrete steps over time, and it actually gives you a step control there. There's also an infinite scroll, which can be useful for some numerical parameters. There's a random, which basically will just randomly change the parameter value. So let's turn that on. It's not super obvious. Let me make it faster and increase the range. Is it on? Whoops. You don't see mine. Oh yeah, that's right. Thanks. Appreciate that. I wonder how long that's been off for. Well, I'm not sure this control is actually working. Let me try to randomize this. This should definitely work. Oh yeah, let me turn the attack down. I think that might be the problem. All right, so yeah, now I have a parameter that's basically just working on a, it's just being moved around random, like the approximate rates every 2 beats that it's gonna change. But yeah, that's a random LFO. Here's another quick detour that I'm gonna take. So some parameters in the synth are one-dimensional. The vast majority of them are just like normal numerical values. There are some parameters that are 2-dimensional. They're basically points in a plane or complex numbers, depending on how you want to think about it. This A parameter, for instance, is one. And you'll notice that when you tap on one of these 2-dimensional parameters, you will either get to choose a way to turn it into a 1-dimensional parameter, so you're only going to be operating on part of the parameter, or you can operate on the entire thing. For a 2-dimensional parameter, you can change the X coordinate, the Y coordinate, you can change its distance from the origin or its angle. Or you can control the entire thing, and if you do that, you get access to a special 2-dimensional LFO. It's a rose curve. It kind of moves like in space. It's pretty neat. Anyways, what else we have going on in here? System actions. Very useful. For instance, you can load a patch when you receive a MIDI signal. You can select a patch. At some point in time, I'm actually going to make the patch selector here, but right now, unfortunately, you have to manually type in a patch name. And we can just trigger this mapping right now. And now we're going to load the init patch. And the attack is how long it takes. So you could have made it really slow. You can make it operate in milliseconds or frames or something like that, but wouldn't really recommend it. And again, the common actions are still here. So you can have a delay. You can have one button press, load one patch, then wait 16 beats and load another patch, then wait 16 more beats and load another patch. So next patch, that basically increments through the patch list, or it cycles through the patch list. So trigger it, it's just going to load the next patch in the library. And it's going to take 4 beats, and you can actually make it go forward or backwards in the library, or skip some number. So we'll load the next one. Reset patch. So every single module on the synth has a init/default patch, and that loads the init patch here. Or no, that's not what this does. So for instance, if you've gone and you've modified a current patch, or the current patch, you toggle this and it'll reset what you've loaded. So yeah, it doesn't actually reset to the default of the instrument, it resets to the default of the patch, if that makes sense. Random patch. So this is going to randomly load from the library a patch. It's not creating a new patch. This is something that's already been saved by somebody. Right now, the only things on this synth are stock patches, so that's what we get here. It's just loading one of the stock patches. So something you can do here, so all of these actions that operate on patches, you can actually select where in the module network you're operating on. So for instance, right now this action is randomly loading a patch at the highest level of the module network. So we can also randomly load a coloring patch. So this is just randomly going to select from one of the existing coloring patches. And that's useful for all of the patch-based actions. So random new, which creates a new patch, right now is operating on the color. So this is just going to randomly create a new color palette. This random new is actually really customizable. So there's a lot of options for this one, which basically lets you control exactly what the randomization does. So there's a lot of on-off toggles. So the randomness basically has an attack like normal. It also has a randomness value. So the way random new works is that it takes the current value of a patch as a starting point and it kind of goes from there. So right now, randomness of 0.5 means it goes 50% of the way from the current patch to something completely and totally new. So if it was randomness of 1.0, then it'd be a completely brand new thing, completely ignoring what was currently loaded. And you can also control what exactly happens when you push or randomize the module or the patch. Random structure actually rewires the module network. Random parameters will randomize the numerical parameters. If LFOs is off, it won't actually do any animation. And similarly for modulation, you can select whether the randomization action actually turns on modulation or not. Save next, you can actually have a MIDI controller button, node on button, basically immediately save a patch with no confirmation. So that's really useful if you don't want to have to type in a patch name and you just want to like smack something and just like immediately save what's happening. So I hook that up on MIDI controller sometimes. So toggle modulation, how does this one even work? I think this will turn modulation on or off on, yeah, that's right. It's basically a way to to use a MIDI controller to turn on and off modulation, which is not super visible right now. But if we go to the init patch, no, I think it's this one. This actually should work. So now it's going to turn modulation on that value or that numerical parameter, on and off. We'll go more into the modulation system next, so you can trying to go fairly quickly. So halt LFOs will basically stop any animation. Although actually, there might be a bug with that at the moment. I'm not 100% sure, but I think there is. Toggle auto basically turns auto mapping on and off, I believe. Or is that the screensaver? I think it's auto mapping. Toggle beat events. When we get to the audio configurator, I'll explain a little bit more about what that is. Toggle camera. So I have a camera plugged in, and this toggle camera action is just going to start using the camera. And then if you press it again, it's going to turn the camera off. Cycle cameras, if you have multiple cameras in, it'll increment the channel. So if you have 2 cameras in, it'll basically swap them. Enable mapping, you can actually have actions turn on and off other actions, and that's what the label configuration is useful for. Random auto mapping, super useful. I have audio stream running into the synth right now, and also a video stream. I'm going to just toggle a random audio auto mapping, so it's going to just randomly load an audio reactive module into the module chain. And now we have auto reactivity. Similarly for video. Now it's just going to randomly load the video modules into the module chain. Toggle auto map. Actually, yeah. So toggle auto map is turning auto mapping on and off. Toggle auto, I believe, is turning the screensaver on and off. Let's actually try that. Yeah, screensaver. It should actually probably say screensaver. And then there's clear buffers. Sometimes the synth can go hyper epileptic, and this button basically kind of resets everything and kind of gets rid of some really spazzy and flashy stuff on occasion. So I think that's all of the actions here. So, yeah. What else is here? So there's also the I/O list right here. So now that we actually have a sense of what mappings are and what they can do, actually let me... Actually, yeah. Let me turn the screensaver back off. Now my button does something. All right, great. So there's a couple more features right here. For instance, if you press shift, you can actually filter the list depending on the type of signal you're looking for. So we only have MIDI controls right now, so there's only MIDI, but actually that's not true right now. We were just, because we came here from the MIDI IO tab, MIDI was selected by default. But for instance, you can see all the CV signals mappings that are currently live here, all the audio mappings, all the UI mappings, so it's what the buttons and knobs are currently doing, and so forth, and then the MIDI mapping we just created. So similarly to learn, there is an unlearn feature on here, and that's what UL is short for. And again, you didn't know that, you could hold down on it to see what that was actually doing. So unlearn sits there and waits for the next signal, and then it will delete. It'll give you the option delete every event that comes from that signal, and yeah, we'll do that. So we've just deleted everything that was on listening for note 36. So a slightly confusing thing about the synth, but worth starting to understand, is where mappings live. So that's what this global down here is all about. And you can also see that on the new page there is a global selection or global selector as well. So more or less mappings live in one of two places. They either live globally, which means they're enabled in pretty much all circumstances, or they can live with the specific patch. So right now it's kind of hard to see. Let's go back to the... Yeah, anyway, no, let's actually see it right here. So we're on... Oh, we created a random patch, which is why... Here, let's just load that. Oh, no, how about that one? So we're on patch fractal 10. We'll go back to the mapping page. And now we see, let's put it on all. So right now we're showing all of the global mappings. If you tap that, you see all of the mappings that are specific to this one patch. So mappings live either in global memory or they live in patch memory, which basically means they're only active when this patch is loaded. And what is now visible right here is basically all mappings that are specific to the patch. And it's just a collection of button mappings, which are the buttons on the synth, and macro controls, which are the knobs on the synth. So it gets a little more confusing than that, though, because you're not actually looking at the patch mappings for patch fractal 10 because it doesn't have any mappings of its own. So it's looking at the default mappings for the instruments. So none of the patches on the synth come with their own mappings except for the init patches. And if you start messing around with the mappings for a specific patch, it's going to copy the mappings from the init patch. So this basically lets you change the mappings for every single patch in one instrument by changing the mappings on the init patch. So the init patch kind of act as the initialization set for all of the other... The init patch's mappings act as the initialization set for all the mappings for the rest of the patches. This is admittedly kind of confusing, but I don't know a way to simplify how it works while retaining the generality, which is kind of a problem throughout the synth in general. So for instance, if you went into the init patch, so here, right now, we see that macro control 1 is hooked up to the parameter c0.r. All right, for the patch that we're on, fractal 10. Now, if we go into the default patch, we can edit its UI mappings. And there's a note right here. Editing the init patch mappings affects every single other patch of the same instrument. So if we change this mapping right now, we're going to be changing the mappings for all of the other patches unless they already have their own mapping saved with them. If you go in and create your own patch and create mappings for this patch, doing this is not going to affect them. So this is basically going to affect patches that don't have mappings of their own. So there's another bit of complexity, and that has to do with the perform page and global mappings. So the knob controls of the knob and button controls of the synth right here, for instance, they don't use global memory. Sorry, this is a little confusing. So mappings live in two different places, and that includes button mappings and knob mappings. They live in the global mapping collection, and they live with individual patches. When you're in perform mode, these mappings right here come from the global IO list. So right now you can see what all of these buttons on the perform mode do and what all the macros do. There's currently 2 pages, and this is how you go in there and change that stuff. When you press shift in perform mode, it then loads from the patch specific knob and button mappings. So the knob and button mappings in the synth are a little special. So normally global mappings are active all the time, no matter where you are in the UI. So if you're in play page, the global mappings are all activated all the time, and it doesn't matter what patch you have loaded. The global mappings are in general loaded all the time, except in perform page. Then it swaps out the patch mappings with the global mappings on. Yeah, so global mappings are available all the time, and patch mappings are available when patches are loaded. But the patch knob and button mappings are not enabled by default in the perform page. You have to push shift to get the patch knob and button mappings. Sorry, this is very confusing. I'm trying to figure out ways to make it less confusing, but it'll probably be a little while till I actually get there. Anyways, sorry about that diversion. So, back to all this stuff. So I think I covered in general the mapping list, the mapping editor, and the MIDI control page. So the last things in specific that I want to touch upon in this video are the other 3 I/O types. Actually, you're gonna have to give me 30 seconds. I'll be right back. All right, I'm back. So yeah, I do also want to slightly apologize for this stream. It is definitely a lot more information dense than I think probably any of the other streams at any point are going to be. I just wanted to be, I mean, I'm going to cover pretty much all corners of the synth at some point in these streams. And this is definitely the most, like, just straight up information that's going to be available in any of these streams. But yeah, I wanted to be comprehensive and touch over this stuff in one of these streams at some point. And I think this stuff is somewhat confusing, both via its complexity and also some parts of the UI design are still a little suboptimal. But yeah, I think the majority of the other streams should be a little bit less like technical and detailed than this one. But I did want to go over all this stuff at some point. All right, so we'll go to the video configurator right now. So something to be aware of, I'm in the middle of rewriting the entire video system, such that hopefully you'll be able to like hot plug cameras and that it won't like crash the synth. So there are definitely some bugs into this part of the synth. I'd recommend not configuring your cameras live. Configure them like right after you boot up the synth, and you definitely shouldn't like plug and unplug stuff while the synth is running. But the general idea is that the synth can support 4 video inputs. In this instrument, if you have more than one, it's going to slow things down. The 4 video inputs is mostly a future preparation. Hopefully in the next like couple of weeks, I'll actually get the cat party update out, and you'll be able to use more video channels at once, basically. So you can tap on this to actually swap the camera slots. So basically on the synth you have 4 camera slots, and you can map arbitrary cameras to the slots, and the slots map to video display modules. And it's mostly used for the modulation system, so we're not going to get into that in great detail here. So to CV, you guys have probably already figured this out. Actually, I probably should have brought a CV cable or something. I'm looking around for one. Anyways, So something to know, you can tap on any of these CV jacks to basically selectively enable or disable any CV ports. You can disable all of them at once. So basically CV jacks only send one signal, just literally the numerical value of the signal from 0 to 1. I think there's 0 to 10 volt jacks. So yeah, it just basically literally divides the voltage by 10, and that's the signal that gets sent. You go to the CV/IO tab and it'll show you all the mappings similar to how it behaves in the MIDI section. You also may have noticed that there's a window size down here. That is used in the modules that directly visualize the CV data. So the synth is basically recording the CV data that comes in at all points in time. And right now it's recording 2 seconds of CV data. So I think the maximum is 8 seconds, but the idea is it just retains some history and then it'll let you like graph the previous window of CV data. And we'll go into that in another video as well, but I just kind of wanted to touch on that real quick. So the last thing I'm going to go over is the general ideas behind the audio reactivity of the synth. I waited till last to go over this because it's definitely the most complicated. But yeah. So the first thing to know, you have a volume meter, and my volume is clearly too loud. So the most important thing you know, which I've probably told you guys on multiple circumstances, and which you can see from this little bit of text right here, is that the volume is expected to be at approximately a certain level for optimal reactivity. And the way you basically want this volume meter to be peaking around this white line right there. And if it's too quiet, you can increase the internal gain. If it's too loud, you can decrease it. Normally it's too quiet, but because I'm running through an audio interface here, it's actually too loud. So at the bottom, there are also I/O controls for the audio system. You can configure where you get the audio signal from, and also it's possible to pass the audio back out. So right now, the only input options are the 1/8" jack and audio interfaces. So if you plug a USB audio interface into the synth, it should pick it up. So you can actually run audio directly in through an interface into the synth. And outputs, if you just tap this, it'll cycle through the available outputs. But right now, you can pass audio directly out of the synth on the back. You can also output over HDMI, which is what I do pretty regularly. And if you have an audio interface, you can output over the audio interface as well. So that's the basic mechanics of getting audio in and out of the synth. But there are 3 general things to be aware of, that actually 4, that you actually do with the audio signal once audio is getting into the synth. The most straightforward thing you do is the synth is listening to the audio and detecting the BPM of the audio. So, like I mentioned earlier in the stream, the synth at all points in time keeps track of a tempo. Whether that tempo is coming from the audio or a MIDI clock or tap tempo is configurable, and you can actually see what it's doing right now. So the system tempo is 117 beats per minute, and it's trying to and failing to actually detect the tempo from the current audio stream, probably because it got too quiet. When this is red, that means it's not successfully detecting the audio's tempo. But one thing to know is you can actually tap on the BPM right now and actually enable various tempo sources. So audio is the audio analysis engine, MIDI is MIDI clock, and manual is a manual set right there, or tap tempo. So a thing to know, if you have both audio running into the synth and a MIDI clock running into the synth, they will conflict with their tempo information. So whichever one sends their information the most recently will basically override the other information. So in order to get around that, you can actually turn on and off sources right here. So you can have a MIDI clock running into the synth and audio tempo analysis running, and just deactivate one of them so they don't conflict with each other. So we see right now that the audio engine is having a little bit better of a time actually extracting the audio. So yeah, like the first tempo is the current tempo of the synth. The next tempo is what the audio analysis engine is actually detecting. So, and yeah, like I was also explaining earlier, there are various units of time in the synth, and one of them is beats, and beat is derived directly from the tempo. The tempo is measured in beats per minute, so the tempo directly transfers a beat to a unit of real world time. So, the other thing, there's two other things to do with the audio. There are beat events or beat signals, which is something I made a couple of years ago, which works okay, but it's definitely been optimized for dance music, and it's pretty intense and ravey. So let me actually go to something a little more dancey in Spotify real quick, and we can play around with that. So there we go. All right, let me zoom in to the controls here so you can actually see what I'm doing. Bring on my camera. So, as well as analyze the synth can analyze and extract the tempo of an incoming audio stream, but can actually detect and predict when beats hit in the synth. So the synth has the ability to respond directly to like a beat in the audio hitting. So it's detecting 120 beats per minute, and we can make it do something every time it detects a beat in the synth or in the audio signal. So when it detects a beat, it's actually going to flash this little button right here. And what I just did is turn this feature on and off. It's off by default, because in my opinion, it's a little bit too ravey and experimental to use most of the time, but sometimes you want that. You see it flashes every time it hits a beat in the music, or every time it successfully hits a beat. So it's a little conservative, and it stops sometimes because the idea is it'd rather miss beats than hit fake beats, and there's a bit of a trade-off. And you can actually go into the settings and kind of mess around with this stuff, which I'm not going to get to in this video because I'm already kind of exhausted. But this basically lets you configure how that kind of stuff works. You can also configure the expected tempo range, which is probably worth pointing out. So the synth is kind of guess the tempo of your audio, and the smaller this range, the better of a job it's going to do, but you might lock yourself out of some existing tempos. So the way the beat reactivity works, every time it detects a beat, it chooses two of these beat actions right here, and it basically just executes them. So right now we have a bunch of beat actions which just increment parameter values. And that's configurable, so you can actually configure what's happening on the beat reactivity. So yeah, every time a beat detects, it chooses two of these and executes it. And like I was saying, this is still kind of an experimental feature that I came up with a couple of years ago. I do plan on revamping it at some point in time and coming up with some better defaults. So I think it has a lot of promise, but there's just been too much other stuff to deal with to actually kind of get around to that. So that's the general overview of this feature. I'm going to go back to more chill music now. All right. So, yeah, that was that feature. There are sort of. So check it out. So you go to the audio mappings list, and you can just edit one of these beat actions. They're just normal actions. So you can definitely just create this. I mean, so right now this one just does this rotation. But instead of triggering it from a beat signal, you can just trigger it from like a MIDI note on. And now I'm just, whoa, something. Except it needs a little bit different configuration. Instead of win always, it needs this threshold thing. Whoops. No. Oh, it's a small amount. Anyways, the answer is... Actually, what even happened here? The answer is more or less. You can't just manually send like a beat signal, but everything that these are doing are controllable via MIDI or any of the other actions. Oh, shoot. All right, so there are two other things you can do with audio. The first two are use the tempo to do something smart. The second one, yeah, so you can trigger it via like any of the triggering methods of the synth. You just can't directly toggle the beat signal that you get from the synth via MIDI, but you can toggle any of the actions. So again, yeah, exactly. You can't fake the beat signal. That would be useful for like testing purposes. Actually, I'm gonna make a note of that for when I actually get around to doing this, because that is actually a good idea. Or you could like have a CV gate signal or something like that. Yeah, modular clock signal, that's exactly right. Yeah, so it will take a modular clock signal. Depends on what you want to do with that. So right now we can't actually get the tempo from modular clock signal. That is on my list of to-dos. I just haven't got around to it. But you can toggle actions on like the rising edge of a clock signal or something like that. 16-note pulse would be too fast for doing anything sensible. But yeah, you can go in and manually configure it to respond properly to modular gates and clocks, but it won't actually use a modular tempo signal like it can. So it can currently read from MIDI clocks, which are, I think, 16-note pulses or something like that, or maybe even more granulation than that. Yes, there is documentation somewhere. That's all the documentation for the parameters is on the synth and in the manual. So, for instance, you can just tap on this and you get a little bit of documentation. Or you can just hold down and it should give you the same information, and it's all in the manual as well. And it'll give you like ranges and basically stuff like that as well. So, back to the audio. Yeah, you can get the tempo from the audio signal. You can use beat events. You can also directly visualize the audio signal. So there are some audio responsive modules. For instance, this module right here is going to texture the square shape with frequency bands from the audio signal. Or at least it would if the audio signal was doing something. See, that's another thing you can do with the audio signal. So there are some modules similar to how there are video modules that visualize video signals. There are some modules that visualize directly the audio signals. And the last thing and the most complicated thing you can do with the audio signals is actually go in here and create audio mappings. So you may not know this, but there is a lot of stuff you can do here. So check this out. Let me actually go back and load the init patch again. And then we're going to go mess with audio mappings. We'll do new. So under the audio tab, there are actually 2 pages of mappings. And these are all various. So first of all, beat's kind of special. Beat is for that beat reactivity feature, but everything else is a signal, which is basically just a waveform that's derived from the incoming audio. So you can sort of fake the beat signal with this beat wave thing right here. All right, so beat wave is a waveform that spikes every time the synth detects a beat, And we need something with a more coherent beat in order to demonstrate that, so I won't get into it. But you also get a bunch of other waveforms here. For instance, you can map the instantaneous volume of the audio signal up to a parameter. We'll map it to the global color, or we'll map it to the global fade control, and we'll put some attack on it of 50 milliseconds to give it a little bit of smoothing. So now the volume of the audio signal, the instantaneous volume over the last some number of milliseconds, will be controlling the fade control. So when everything is quiet, the synth should be faded out. And when the audio picks up, then yeah, the synth should not be faded out. There are a bunch of other signals you have available here as well. Average volume gives you the audio over the past like 2 seconds or something like that. So it's a little bit less abrupt than this one. So basically when I turn the audio off, it'll fade out to some degree. Yeah, over a little bit more slowly, and then we turn the audio back on. There you go. Fundamental frequency, so there's some of these that are kind of obtuse. Fundamental frequency, if you actually play like a melody in here, it'll give you a value from 0 to 1 that kind of tracks the central pitch of the actual audio signal, and will let you basically like control some parameter value by the fundamental pitch of something you're feeding into here. And that works similarly to max FFT band. So max FFT band gives you a value from 0 to 1, which basically tells you which bin has the most energy in it. So when it's closer to 0, that means you have mostly low frequency energy in your audio signal. There's a couple other more advanced things in here. So low frequency energy gives you basically a waveform that tells you how much energy is in the low frequency band. So this kind of spikes on bass notes and kick drums and stuff like that. But you could, for instance, map the low frequency energy up to the red level and basically turn off all of the red unless there's low frequency coming in from the audio signal. There's some even more obtuse ones in here, like noisiness. That tells you how similar to white noise your audio signal is. So you can use that, for instance, to detect like snares or risers or stuff like that. Hit rate gives you a measure of how complex the audio is. And again, you can long press on these to actually get some information about what's going on here. Oh, that's not good. That's a UI issue. So if we go into help from here, it will delete everything you're working on. That's great. Hit wave is similar, except it's actually more in... Yeah, so hit wave is sort of like detecting beats, except it detects like all kind of introduction of new content in the audio stream. It's definitely pretty sophisticated. I would suggest just playing around with it. Anyways, I am exhausted. I apologize for all this information, but that was like a massive brain dump of basically everything you can do with all the I/O on the synth. So I'm available for questions now. If nobody has any questions, I'll just go in here and start messing around with stuff, because that is always fun. So yeah, let me turn off some of this stuff. Yeah, I think what I'm going to do is spend the next 15 minutes making a patch and then just try to wire up some of these audio signals. Yeah, so there is a way to back up patches to USB, not settings though. What's going on here? Oh, there we go. Yeah. Yeah, so definitely in the pipeline is a bunch of online features where you can share share patches and presets. And yeah, actually backing up the synth is not a bad idea as well. Right now, you can just plug in a USB stick and it should transfer all of your patches to the USB stick in settings. I think there's like a option that pops up somewhere, which is basically backup synth or something. I forget what it is. And you can plug that into another synth and it'll detect the patches and it'll load them onto there. So you can back up your patches. It's not going to save images and it's not going to save settings, but we'll get around to that at some point. So the random patch generation, does that make any of these audio IO mappings automatically? I don't believe so. I've thought about that, but I just haven't got around to that either. So that's not quite exact, or quite accurate about the patch mappings and macros overriding global ones. So the idea is global ones are always active, and patch mappings are always active when the patch is live. So there is no overriding in general in the synth. It's just they're always both active. Except in perform mode, and then it deactivates the knob and button mappings for the patch unless you're pushing shift. So you can have like 17 actions hooked up to a knob or a button, and if global mappings, or like 17 mappings hooked up to like a MIDI control, and if both global mappings and the patch mappings have those mappings in there, they'll all be active. And the only weird bit about that is that patch, knob, and button mappings aren't active on perform by default. Yeah, so you can save all of your patches to a USB stick. You can't individually save patches, but I might actually do that sooner rather than later, so people can start sharing patches, where it'll just bundle up your patch and put an individual one on a USB stick, and then you can upload it somewhere online, and then somebody should be able to download it. But so it feels like something you'd want stuck at a system level to have a consistent thing for your setup. I'm not sure which thing feels like that. If you want to elaborate, I can talk more about that. I'm not sure exactly what you're referring to, Moogly. All right, so I'm going to start with the init patch, and then we're just going to build something. Oh, the audio routing. Yeah, so that is savable at basically the system level. That's basically what global mapping memory is. I don't know if you caught that part of the whole rambling bit, but anything saved into the global IO mappings is basically at a system level. So no, that's not accurate, not quite accurate quality. Apology. Yeah, another thing. So the global mappings. So first of all, global mappings for knobs and buttons are only active in perform. That's another thing worth knowing. So global mappings for MIDI, CV, and audio are active all the time. Global mappings for buttons and knob pushes are only active in perform. So I actually need to make a third category of IO mappings, one that's just for perform, and then it will get rid of all this confusion. But at the moment, global mappings for knobs and buttons are only active in perform. So if you wanted the buttons and dials to do different things for patch, then all you need to do is save different button and knob controls per patch. That's all you have to do. So you don't need to play around with the global mappings for that unless you're trying to configure the perform page. All right, so we're diving into the seed right now, and I'm just going to start with parallel set of lines. Actually, no, how about we start with a solid, completely solid image. All right. Now, for the texture, we're going to use... We're going to use the output texture? No. We're going to use one of the generative textures, which is blank at the moment, but I'll fix that in a second. So I really like this guy. There we go. I got some squares. Actually, no. I'm gonna switch to not. How about this thing? We're gonna use this one. Now I'm gonna turn the stripe on to add some transparency. Actually, we're gonna use one of these audio stripes to make it audio reactive and give us transparency. So, like I was saying, there are some modules that respond to audio, and this is one of them. So right now, the stripe, the way the stripe works in the seed, if you didn't catch the last stream, was the stripe is basically a way of injecting transparency and other shapes into the seed module. So for instance, I can go to preview just the seed module to show what it's actually doing. So this is the seed, and the stripe is responsible for all these horizontal black lines that are audio reactive, and those are transparent areas in the seed. So now the audio is stopped, you have lost the transparency. So I'm going to go into the recurse module, and I'm going to turn off the kaleidoscoping. All right. Now zoom out a little bit. And then I'm going to try bending the screen a little bit. Seems like is the music just too quiet? It is way too jittery. I think that audio reactive seed is doing way too much. Yeah, let's go in and change that around. Let's just use this one. And there we go. I'm gonna put an LFO on this because why not? It might look terrible. Who knows? Oh, I don't think I can actually do that from this page. Well, scratch that. I can do it from here though. I'm going to make the angle from this parameter just continuously go around in a circle. There we go. Now we can actually go right here and you can see the LFO is active for this parameter. All right, now, I wonder if this is, yeah, it's gonna work. All right, now I'm gonna go mess around with the color module. So I'm just gonna start from a random color palette. Kind of like this. Let me actually go back to the slightly different view. There we go. All right, now we're going to just randomly add audio reactivity to this patch. So I'm going to dive into the modulation system in detail next stream. So I'm not going to touch on it in too great of a detail. So definitely tune in next week for an explanation of what's going on here. But the basic idea behind the modulation module is that... it's generating these 4 auxiliary patterns. And some of these auxiliary patterns, as you can see, are audio reactive. And then it uses these auxiliary patterns elsewhere in the synth to do stuff. And I'm just swapping out the modulation subchain. All right. I think I like the first one the best. That's too fast. You know what I can do? I don't like this. I'm going to start from scratch. Actually, I'm just going to push random and see what happens. This is getting nowhere quick. There we go. All right, I'm going to go into the seed module and swap out this module with an audio reactive one. It's a little too faint. It's like 4 or 5 audio reactive waveforms in here. Yeah, you can preview every module, every single one, like even these waveforms. Some of them have like really crappy preview views, but they're all visualizable. This is basically what's used to generate the thumbnails. I don't like this effect. I want to slow down whatever's pulsing in and out, which is I think it's probably this because that's the fastest one. There we go. No, preview is definitely not static at all. I mean, you can see the modulation pattern being generated dynamically here. We could, let's load like an audio one. It's a live animation. And we've just loaded audio reactive modules into the synth too. So I am going to change some of these effects, I think. Oh, no, this effect's not even on. So I definitely don't like the color. So I'm going to load like a different lighting chain, see what happens. Well, I made it worse. Let's just swap out the entire color chain. I really do need to implement an undo button in here at some point because I just definitely made this patch way worse. This isn't terrible. Oh, what? All right, partially salvaged. All right, I'm gonna play around with the shape a little bit more. It's the easiest way to make this slightly more colorful, but not entirely. I think we're going to go into the color module and use the mixer effect. Actually, no, I think we could just use one of these other effects to add some color. I turn the effect on. But I only want to do that like selectively. That helped. Alright, I'm going to save this before I screw something up again. There's like an image in the background. I'm kind of wondering where that's coming from. It's coming from modulation channel 2. There we go. Alright, let's play around with some of these audio mappings. Let's try volume. We're just gonna set a value. Didn't do anything obvious. All right. Why is that even? Huh. That's surprising. This should definitely be doing something. Maybe I need to save it in the global mapping group or something. I think that actually is working now. No, it's not at all. What the hell's going on? Well, that's clearly some kind of bug. I don't know why this isn't working. Alright, well, I'm a little confused why that's not working. So, there's a width control right here. And I should have a mapping in global memory from low frequency energy to the width value. Yeah, so there's clearly some kind of bug going on. I have no idea what it is. Maybe the audio analysis engine crashed or something? I really don't know. Maybe it doesn't like the width parameter. See, that works the way I'd expect it to. Yeah, so it might not be generating the audio events for some reason. I swear it was working earlier. I don't really know what happened. I think I might have to debug this later. Anyways, well, I think that might be a sign for me to call it because I am exhausted. Again, I slightly apologize for just the massive information dump. I think the rest of the streams won't be quite as just tedious and just like such a sheer volume of information. But I hope you guys pick something up or learn something. Definitely let me know if you have any particular topics you'd like me to cover in some of these streams in the future. But I think the general trajectory is going to be that I go over the modulation system in the next video. I mostly use slow LFOs for music reactivity, but with an ambient audio stream, you might not be able to get the tempo of the audio, so you might be better off using some of these audio signals. I do need to figure out what's going on here and why it's actually not generating them, but I'll get that sorted at some point. Yeah, my pleasure. So, like I was saying, in general, the next stream is going to go over the modulation system, and it's probably going to be the last one that's kind of technical. It won't be nearly as technical as this one, but there is still a lot of stuff going on in the modulation system. You can create like weird feedback loops there. Yeah, I'm not really too sure. I'll definitely get it sorted. I have no idea what's going on, but I will definitely figure that out. After the modulation system kind of overview and tutorial, it's going to be a little more focused on doing like specific cool things with the synth, like exploring some of the... It's going to be more focused on like actually building patches and like creating content. It's going to be content focused basically as opposed to information focused, if that makes sense. So we'll go through the instruments and like kind of dive into building stuff out of them. I'll show off some of like the mixer effects and kind of cool stuff you can do with that. And then yeah, once we start integrating the modulation system, you can start doing a whole bunch of really cool stuff. So yeah, after the next stream, it's going to switch over to being predominantly content focused, I think. So yeah, anyways, I really hope you guys learned a lot, and thanks for swinging by. Really appreciate it, and I'll see you guys next week.